Matt.
Sage, I'm also jealous of your sunlight in the background. It's cloudy here. I imagine you'll get in a day.
Probably. Yep, it's
I don't think Wisconsin is actually sunny, so there may be the notice the weather.
It usually is. Actually, it's sunny most of the winter, which is sort of weird. Freezing cold.
Totally.
Yeah, the Midwest is sunnier than like Seattle is. It's not as
I've lived
bad.
everywhere from Chicago up through most of Michigan, most of Lower Peninsula, Michigan, and we've never had sun. So you guys do not have sun.
You probably
the asking is whether Sage is really in Wisconsin.
You're surrounded by water on like three sides. Matt, you're surrounded by water on three sides. You get all the.
Aren't they? I guess not quite on the trees. On one side, anyway, and all the way up north. But okay. Yep.
Yeah. Enough of a buffer, at least. All right. Let's see. There's the page alignment thing from ARM folks, because pages are sometimes 64K. So allocating 64 pages for alignment is stupid and total overkill, because usually when we align to pages, we're doing it for direct IO and we actually need 4K alignment, so whatever. So that merged. There's an RBD thing. Patrick's thing to change the logging stuff to avoid the heap. Looks like it's mostly ready. I haven't actually followed that in detail, but I'm just trusting that Patrick and I think Casey and whoever else is looking at that know what they're doing. The Blue Store shard thread one is interesting, because I think I'm still, it's a pretty significant change, and the initial performance results that he posted were like, it's slightly better in some cases and slightly worse in other cases, or a fair bit better in some cases and slightly worse in some cases. So I'm curious, after all the changes, if he's repeated the performance test. Do you know, Mark, have you been following this one at all?
I haven't really been closely following it, other than that it seemed murky, so I didn't look into it any.
Just a little worried because he's spending a lot of effort getting it to pass all the testing, and I'm not really convinced we should merge it yet.
Yeah, I can take a look. I'll see if there's anything more with it. But do you?
Maybe.
Is it? Go ahead.
And maybe yes, ask him. Get us updated performance tests with the latest code that we can review to make a final decision there. Okay. Your cache binning thing is
broken.
Work in progress. Still finding that test. There's some perf counter stuff from Radic. Crypto stuff from Peter. Is he here? No. Let's see how that goes.
With my thing, I noticed that there was like some talk about TC-malloc being broken, like older versions being broken, and another PR that Keithu was working on. There was actually just like an update to it recently.
Yeah.
But, there's no possibility that we're hitting something with like an older version of TC-malloc in the QA suite, right?
But I think there is definitely a possibility.
Okay, because there was like a segmentation fault issue with something related to like old versions of TC-malloc.
Maybe send a link to the crash that you saw with that suite to Kifu and ask him if it looks like it might be related.
Okay. Yeah,
I understand which the other thing is happening. So.
Okay. Yeah, I'll talk to Kifu about it. Before I spend hours trying to track this down, then maybe I'll just make sure it doesn't. Yeah, there's not that possibility.
Yeah. Yep. Radic, what's the current status of this crypto one, 23260 refactor to use OpenSSL's EVP API from Peter?
There was a blocker. For testing in OSD. At the moment, we have only results from unit tests. Well, I'm not sure whether they are conclusive. will love to see results from a cluster running, for instance, RBD workload. Okay, I will ping Peter today.
Okay. Boom, boom, boom. All right. There's a tiny appends thing from Igor that still needs more discussion, I think. I guess that's mostly it. Where's this op tracker and request queue path? What's the status of this one? 3071.
It waits for review. However, in Vancouver there was some talk about op tracker, and it seems that it won't be in current shape in the sister world. So we need to take maybe even deeper rework.
Yeah, definitely. I think this would be a short-term performance hack for Nautilus, I guess. But I guess the question is, what's the net here? Is it this worth?
Well, the number of changes is big. Maybe if it's a problem, maybe we can dissect most critical parts and merge, especially those parts that are unrelated to op tracker.
Yeah. Yeah. I mean, I think we want the power 2 stuff introduced into the config. We want that.
Okay, I can to make the PR smaller and less controversial. I can just dissect those things and send separately.
Okay. Yeah, let's start with that. And then if there are significant wins on just optimize the current op tracker stuff, then we should do that. But yeah, I mean, all of this is in full awareness that the C-star SD is not going to reuse any of this code, probably.
Yeah.
It's going to be different. But that's fine. It's a ways away, so it'll take time before we get there anyway. Yeah, here's the pad link. All right. I think that's it on these pull requests.
So Sage, last week we had a long discussion about buffer list. And
Okay.
you can, if you scroll down in the pad, you can see just a very high level overview of some of this. But the gist of it is that I think we all agreed that we don't really have a good idea of what how different parts of the code use buffer list and what's really required in different places for it. And
Yeah.
Radek's the only one that's actually doing anything about it. So I think he's got an update of looking at like TPOSD TP threads, but
yeah, I made some profiling at the moment only for Ceph OSD. I haven't verified any other parts of the system like librbd, like Rados Gateway, and just pasted the link. Seems that well, at least maybe it's a matter also of instrumentation. I had to introduce to make to disallow inlining of the encode stuff. But well, it seems that the overhead is not particularly big. I guess the most interesting thing is the it's the third snippet for the 4K random writes profiling. Well, we definitely could try to recompute the size using bound encode before encoding. This should cut a lot of allocations we have there, but still at least for the encoding part, the overhead is not so particularly big. When it comes to other, when it comes to other use cases for buffer list in OSD, also took some look on that, and it seems that we fixed two biggest issues. One was the encode sum in Blue Star, fixed by Igor 1 year ago, something like that. The second one was in Messenger. It was the crypto interface. We had a buffer list in there. They were very, very costly, around 50% of IOPS. But after that, there is no huge one huge user of buffer list. At
So
least in
Radek,
OSD.
in reality, though, this is times 16, right? Because we have in your test, you said you had 16 TP-OSD TP threads.
Well, two different recordings. First one, when it's not specified, it means there was that the whole Ceph OSD process has been captured. If mentioned otherwise, only one single TP-OSD TP thread from this process.
So, like, I'm specifically looking at the section profiling single TP-OSD TP thread where I see like 1.4% time in PG log entry T in your GIST.
Yep.
Is that times 16 or is that just?
No, it won't be.
Okay.
It won't be because when it comes to random writes, we are usually blocked by the single KV sync thread.
Yes, I guess what I was wondering
So
is that
means
is
that the TP that the yep.
Okay.
This I guess I have a feeling that this translates into much less overhead in TP, much less work in TP-OSD TP. The pool is just waiting for the single guy.
Yes. Yeah.
So basically, you will have maybe 3 active thread. Messenger, one of the messengers, TP, OSD TP, and the single KV sync. Plus also some workload made by some work performed by KV final and finishers, but not too much.
Did you profile the TP-OSD TP thread in the rand read case?
No, I didn't. But it seems that for rand reads, well, we don't in such scenario we don't have any single place like KV sync thread. So the share of the TP-OSD TP pool in the wall in the all samples made for captured for whole process is much bigger. They are dominating. So if you don't see, I thought that if we don't see any huge load on per process view, then there is little sense in profiling single OSD TP. OSD TP.
I'm also curious in the write case if we weren't blocked by the KV sync thread. Like as an example, if you put lots of OSDs on one NVMe drive, so you're kind of working around it by just sharding OSDs, so you've got essentially multiple KV sync threads. I wonder if you'd start seeing any difference in the way that the TP-OSD TP thread overall cycle counts, if they'd look different.
Do you mean a scenario with? Sorry, could you repeat the conditions?
So the way that people tend to work around the bstore KV sync thread bottleneck is they just deploy lots of OSDs to one NVMe drive.
Yeah. That's the scenario practiced by Intel, and so that in tests. Well, as a result,
I'm curious. Yeah. because like you said, right, this is in the 4K rand read case or rand write case, we are almost certainly bottlenecked on the bstore KV sync. That's what we always
Yeah.
see all the time.
All the time.
But maybe if that starts going away, I'm curious how the numbers in the TPOSD TP thread change.
Okay, got it. I haven't profiled that in today,
Yeah, no, and it's
but might be interesting.
I swear I've seen numbers higher than this before, and I don't remember in what scenario I did, but I think there's the potential for like the PG log entry T and some of these other ones to go higher.
Yep. But in such situations, it's the TPOSD TP pool, the size of the pool per device can be very large, around 64 workers per single device.
I'm missing some context here. Are we talking about the gist that you pasted in the chat?
Yes. So
Okay.
Well, we started from
unless we're we're
Yeah.
talking about totally different things,
I
which
can't-
is kind of funny.
I can't tell what we're talking about anymore. I got lost a little while ago.
Sage, we're trying to figure out how much overhead there is for encoding in non-Blue Store stuff.
Just in general. I mean, this looks pretty modest. To be honest, this isn't terribly worrying.
And that's and my argument, I guess, is that I think I've seen higher numbers than this in other scenarios.
Yeah. This is a random rate.
With
Yep,
one OSD on a fast
random.
NVMe device.
Yeah.
Yes. The cluster was deployed by vstart without the bugs messenger.
Yeah.
So of course without the log dep. So 3 fast devices and 3 OSDs.
Okay.
Is TCmalloc thread cache set high, or was it set to the default?
Nope, it's default. It's just vstart testing.
We need to figure out a way. We need to make vstart start actually like deploying with high thread cache, I think.
Why?
Yep. Right.
If people are doing
Why
like
do we-
benchmarks with it,
Why do we need I thought the defaults were fine now that we had a small thread count.
I don't believe that unless I see someone prove it with numbers. Still have a lot of threads. I mean,
We had
maybe.
I know this scenario. I don't want to interrupt the flow so much, but I have specific action items for TC Malloc and sort of questions to answer about it that I don't know if we spent a lot of good effort a couple of years ago learning a lot. Mark, you did, I guess, learning a lot about the different allocators at the state they were in at the time. This possibility that there are bugs or problems with older versions of TC Malloc is out there. I have downstream concerns for that and need to sort of solve it on the Luminous baseline for that. We have in the past we didn't link RGW with TC Malloc. Now we do, and Luminous and above. This could be a threat. If we saw a problem with linkage of TC Malloc and on Joule in some environments. Doing to Xenial specifically, which we didn't see elsewhere, but we think it could be there. We have some upstream information too that there are workloads this may be vary by TC Malloc version, but I actually haven't any concrete proof that that's the case. There are workloads that show up extraordinarily high activation of GC operations in TC Malloc, like specifically returning memory slabs to central free list.
Yeah.
And it can show up as a meltdown of a daemon that run, when we get in some cycle like that. And I don't know which TC Mallocs do and don't do it, or if they all do it.
We do have we do have this nasty allocation pattern where memory is allocated by other thread and deallocated in another one.
Yep.
It's
Sage,
especially be a bit.
To follow up with what you were just saying, though, the tests where we saw that like the async messenger wasn't as dependent on high thread cache values was absolutely true. I mean, but those tests were done back in like the file store days when our performance on NVMe was way lower than it is now. We've improved things dramatically since then. So I don't know that I would
Okay.
trust that
Well,
TC-malloc doesn't have an effect on
let's-
things.
Maybe we should repeat that test then and see if it does make sense. Because I've been telling people that no allocator tuning is necessary at this point because
I
we
think-
switched to async messenger. But if that's
I
not
think
actually
that's-
true, then we should find out.
Yeah. I think it's probably true insofar as async messenger versus simple messenger goes, but I don't know
Yeah.
that it's true in terms of any of the rest of the stack.
Right. Well, we can just do async messenger with default and async with enlarge and increased or cache, whatever
Yeah.
the right word is. And
Yeah.
let's see. Yep. Okay.
It's quite possible that file store from like 2 or 3 years ago was enough of a bottleneck on NVMe that it just never mattered, right?
Yep. Oh, we can find out.
Cool. I'll add it to the
Um,
list of stuff to do.
All right. Yeah, I mean these encode profiles that you have, Radek, don't actually worry me. They seem pretty reasonable. So I don't know.
I
don't know
worry
that
about
would do it.
I would worry about secondary effects though, Sage. I mean, yeah, maybe these are like cycle numbers, right? Like perf recordings from just these things, but what
Yes,
does the
but-
effect of doing lots of small allocations have on the rest of the
Yeah.
yeah.
Yep. I mean, but I would focus my efforts on in other areas first, I guess. Cleaning out all the cruft from the bufferless class sounds great. It sounds like the small vector experiments there didn't work out terribly well, but I'd want to square that with what Mohammed did last year because I thought he showed better results. I guess he was only doing micro benchmarks, so I didn't actually run the whole thing.
One thing, Sage, with small vectors, all you really get right now is just avoiding the double dereference, right? Pointer dereference, because you still have all these little small car star arrays, right? So you're still
The actual raw buffers are still allocated elsewhere.
Yep.
I mean, yeah.
so you don't really get stack allocation. You get stack allocation of the small vector. But it's
Well,
still
you
a bunch
eliminate
of
the intermediate, right? The
Yes.
list nodes. You eliminate the list nodes as an in between.
That's
Yeah.
but that's all you do. You don't get any
Yeah.
kind of benefit to avoiding like memory
Right.
fragmentation. Small
Yeah, I mean, I think
point.
what we really want is to move to the C star buffer primitives and avoid the complexity that bufferless introduce. Because I think for most of the OSDIO path, it's not actually necessary.
Yeah, that's very interesting. And then Radoslav was emphasizing that. So you mean for in general in the code base, if we could get there.
I think for the C star OSD rewrite, it should just avoid bufferless entirely for the IO path.
Well, that makes perfect sense. But I mean, is there a way to get it into the general code base? I mean, is there a possibility of attacking more?
That's a much harder problem. So I don't know.
Yeah, there's also the issue of thread safety because the C star ones are doing non-atomic ref counting for the sharing, so that wouldn't work in the normal threaded world.
Yeah.
But even
I think
in
we
the
can-
wo- in,
Sorry, go ahead.
sorry, please continue. Even in the current world, we can optimize the ref counting, at least for the situation where buffer pointers and buffer rows aren't shared.
Yeah, if we know when those
For me,
cases are. I guess it's
started working in that direction. However, from the profiling, I would say that this won't bring a huge benefit, but maybe still worth doing because it's small.
Well, the other thing you brought up in last week that I thought was interesting was the apparent cost of iterator invalidation.
Yeah, but however, when it comes to such complex things, I would give a try to something much simpler. At the moment, the buffer library is not header only library. We have very important, very frequented parts of the path put in CC. We found possibilities to inline the code. It applies even to advancing an iterator over a buffer pointer. I guess we would really want to move to header-only library. I can recall the try small vector. It was associated with inlining some critical stuff, shuffling some critical stuff to allow inlining, and at least in micro benchmarks, it gave huge benefits, around 3 times.
Yep, that seems like something worth pursuing. But again, the very first thing I would do would be to rip out the splice stuff, rebase that branch and get it merged, and to rip out the CRC cache and verify that it doesn't matter.
It's not even for performance. It's just
exactly
even it's
maintainability.
to cleaning up the code.
Yep.
And then some judicious inlining, perhaps. And then for the C star, we should sort of carefully find that balance between adding just enough complexity to do what we need to do, but no more. Because the buffer list is motivated by like being able to do anything and everything. And there's just too much there that we don't really need most of the time. So.
One of the discussion topics from last week was
one last thing. I think perhaps the last thing that we should consider also is actually not specifically related to buffer list, but it's the container allocator thing that Alan proposed forever ago, where we can selectively reserve space inline in the structure to allocate container items. I think that might work better than, because we can sort of, if we have that general tool in our toolbox, then we can apply it, not even just to this, but in other places too. Right.
I was one time I already resurrected that, but I guess I will need to make another rebase.
Yeah, but but you have a list of like 10 things on your like need to resurrect and rebase list. So I want to like make sure we sort of do the ones that are easy and we can actually finish instead of having 10 in flight. Be my suggestion. So.
Okay.
So yes, I think we should resurrect that, but let's wrap up some of these other things first.
What's top on your list, Sage? Like what?
I mean, as far as buffer stuff goes, just ripping out the old code is quick and easy. Let's start there. I think getting the op tracker thing wrapped up. I mean, if you look at your open pull requests, you've got like 20 some things that are all like sort of half finished. It'd be nice to like figure out which ones we want to actually finish or abandon. Otherwise, we're just spinning our wheels optimizing things and then never actually getting any of the benefit.
Sage, one of the things I still, at least personally, and I'm maybe it's just my own fault, but I don't feel like I have a really good understanding of how different parts of the code are actually using buffer list and what they need and what they don't need and what, if they're even using it in a really sane way or not.
It's unfortunately a mixed bag. I think in most of the I/O path, buffer list is used very sort of carefully. At least for the right path, it's all one big buffer basically. It's passed all the way down, and we're taking subsets of it, and that's all great. On the read path, it's a little bit more complicated because things are coming out of the cache. So you have blue store blobs, and those are getting pieced together for the final result that goes over the wire. So there we actually we make use of the dynamic listy nature of it. But beyond that, in the OSD, it's mostly clean except message encoding. And the main messages are fine. MOSDOP is relatively careful. The way that transaction is encoded is somewhat careful, I guess. But those are sort of unknown size and unbounded, and so they need that sort of dynamic encoding stuff. On the metadata server, it's a pretty different picture. There, we sort of more aggressively use the buffer list to like string together arbitrarily complicated and crazy things, and we're encoding big hunks of complicated tree structures of metadata and sending them over the wire to the other metadata servers with balancing stuff, and that makes heavy use of buffer list. So
And for any of that stuff, either on the read path in the OSD side or in the MDS, can we do the same thing we did in Blue Store, where we can like pre-compute the size of things and do one
Maybe.
like big allocation?
I have to refresh my memory. I seem to recall that the Denk and encoder stuff does glue together, but I think it's awkward when you make the transition. I can't remember exactly I can't remember exactly what the impact is if you have just a random, you're doing traditional bufferless style encoding of a bunch of random stuff, and then you hit some random leaf item that's a Denk style encoded atom. I can't remember how smart it is.
Okay.
I think it works okay, but yeah, that might help. But the Denk stuff is a little bit weird because it's a two-phase traversal. It traverses the structure once to figure out how big it's going to be, and then it traverses it again to actually
Yep.
coding.
Yep.
But
So we have to be a little bit
That seems-
careful using that on really big structures.
It seems like that's still a win as opposed to doing like lots of small appends, though.
Yeah, I mean, depending on how efficient the appends are. Yeah.
Yeah, very true.
I
But
can I can recall from encode some of Bluester's extent map that the bound phase was extremely non-costly. It was extremely cheap.
Yeah. Well,
It's many of that such things can be made by can be optimized out in compile time in compile time.
yeah, and it's meant to be conservative too, so it's a bound, and so it'll sort of overestimate to be fast. But I think the open question in my mind is what happens when it's a really big complicated structure, like you have a map of maps of strings or something like that. So probably that can be answered with some unit tests, just benchmarking encoding versus with the two different styles and see what happens. But I'm a little bit hesitant to like more aggressively convert everything to be Denk style instead of the traditional style.
But as far as I understood the code, there is no one macro, one function or something like that, one entity that would call both bound encode and encode for you. It's basically employing the bound encode is delegated solely to the user of buffer list, to a programmer putting.
It's at the very edge where it actually is the encode wrapper, I guess, at the very end. Has to find out how big of a buffer to allocate. And so it calls in and traverses the whole, does a depth first traversal and then allocates a buffer and then does a depth first traversal to encode.
Maybe it will be useful to prepare some macros for that case. Encode root or something like that.
I think those already exist. I think those are the encode wrappers.
Okay, haven't found them. We'll take another look.
If I'm understanding correctly, at least. Yeah. Anyway, on the buffer side of things, though, I would start with cleanup, and then looking at judicious inlining, I think, and then I'm still surprised by the small vector versus the result that it wasn't fast. So I'd probably want to square that with what Mohammed saw before.
I posted East. Maybe can explain what's the reason. It seems that yes, that traversing the underscore buffer container now is much cheaper. But to fight the issues with pointers with iterators invalidation, I introduced another memory indirection layer. That seems pretty costly.
Yep.
So finally, the iteration not over buffers, but the iteration over buffer list at wall is well slightly more expensive.
Yep. Yep.
this is so in that regard, if we can do everything to do like a one big upfront allocation and then be able to tell kind of whether or not that would fit into something simple on the stack. I wonder if that whole side of it would be much faster. If that kind of makes any sense.
Could be.
Kind of doing away with all of that, doing away with iterators entirely almost. You just have a very simple.
If I'm understanding this problem, it's buffer list iterator advance. That's the problem, and it's because it has to recalculate which buffer in the vector it's pointing to. Is that right?
I think so. If we switch, if the cost can be even more visible when after switching to one big allocation made at the very beginning, because in such scenario, cost of traversing the underscore buffer will be negligible. The iteration over the wall buffer will become.
And the problem was because underscore buffer can get reallocated, and so we can't store a pointer into it. We have to store an offset and then dereference it each time. That was it, right? Because we could have a flag, like a bool that says that I reallocated, and every time we reallocate or resize that buffer vector, the flag, and so we only have to selectively dereference. Did you try that? I don't know if that conditional.
Not yet.
Because that conditional might be cheaper than an unconditional dereference.
Might be.
Yeah.
Yep.
Radek, if you try that, I think we need to test this independently of the inlining, though.
Yes, that's the idea.
Yeah.
Inlining changes a lot.
Yep.
All right. Well, it sounds to me like there's plenty to do to get to the next phase there, and then we'll know more once we do that. All right, Matt, do you want to talk about key value OMAP?
Sure, or at least I'll try. I want to. There's nothing that I can bring up that hasn't been brought up in some form in 90 other times. but I want to concentrate on the pieces that interest me at the moment.
Okay.
And I think at a high level we continue to. I think I created a little tiny. Mini reading list and a 3-point bullet thing, which I'll paste in the chat. Not taking it in the chat. Maybe it'll put it in the chat now. It is not currently doing it. Is there a place where I can stick it in the
the pad, or
if it's just
the pad? Where in the pad should it go?
Just stick it down in the discussion topics under your
line 95.
There.
Perfect. Thank you for the number. Okay. There we go.
Okay,
there's good things. Basically, this has an on-topic front part, which I call relevant, and then an off-topic point, which is to point out that one, since 2016, there's a whole cottage industry of discussion about the key value store problem in main memory mainly, but of course it ranks off into other places. It ramifies into directions we're for everyone who like us who cares about primarily about being consumers of key value interfaces or historically done so for various reasons. May get sucked into them, but I think the key piece I've taken away is this was an area of prior expertise. This aspect of database construction was not an area of implementation expertise for me. But I'll take away point one. We as a group have to become so. And that requires us to think about we got a lot of mileage out of in particular RocksDB and the work that Google and others already did there. But point one, I think this is pretty evident in a lot of different literature, but I take it to be summarized nicely and maybe pretty brilliantly actually by the Apache Dude folks in Wisconsin. There's in the Whiskey paper where they showed how you could do something really tiny to help a lot. But basically, LSM is a dead end. I think Alan Samuel for us, and Alan Samuel has claimed that also and made clear some of the reason why. But there seem to be two reasons why. One is that it moves too much data around, and the other is the size of the in-memory acceleration required. Just the relative size of the Bloom filters and other and memory table and all the relative to the amount of data being stored. We hit both, which leads to both of which lead to the behavior we see at runtime, which is issues with compaction. But it's also imposing a limit on the size of the log scale, of the nicely log scaling behavior of the index much earlier than we want, much earlier than a competitor or a system would. In addition to the higher cost of reorganization. And the whole aspect of how we got here and how RocksDB and LevelDB became such a useful thingamabob at this state of at this point in history of index data is interesting. But it appears that most other things, the way forward is likely to be, at least in terms of organization, is where you would have thought it would be all along, and where it is in classical databases, which is B trees and clustered index technology, more or less. Of interest, though, is prefix trees, because I think this appears to be a part of things people are building now. And there's a nice paper on that, and that came from Korea Institute of Technology, and a bunch of people have worked on it. It almost got to a point where people were working on an open source project that could be used as a thingamabob in the same way we, as a piece of common commercial off the shelf junk we could just use the way we do RocksDB, but that didn't quite develop. I think that's an interesting. Yeah, that's right. Because one of the members of the team, the primary, the lead PhD candidate from that group, Young-Sun An. If I'm saying his name right, I apologize if not. Both built a bunch of prototypes and then went to Couchbase and worked with and got it to a team of 3 people. Worked on a sort of off the shelf user space library that would do this, and almost got it to a productized point and then quit. Young-Sun An went to work for eBay. I've talked to him a little bit, and I've talked to his former colleagues. Both of them have chickened out of open source collaboration around this stuff. But there is quite a lot of useful code, and it seems to, and kind of the Couchbase stuff has some interesting properties. One, it's mostly intact. It's mostly completely describes, one set of things, and it sort of works in user spaces. But it hasn't been exhaustively optimized and dragged into a complex, form with a lot of dependency on specific primitives like various lock-free paradigms and map and all that, whatever other junk. So I and the other angle that that has been in this community before and it came back in recently, apparently at Mount Point, is that a lot of people working at a low level on Flash optimization, have a bunch of things that they're concerned with. And if you look at the Zettascale code base, which I did briefly, there's almost no high level index material, work in it. It's all of their FTL. It's all their FTL, Flash optimization code base. But I think we may care about that. I don't know, especially in the C-store development space, or maybe we can collaborate with others on that. But I think it's a distraction. I think at least I think the piece I would like to bring to our attention and concentrate on is index structure. And in particular, how we could exploit that in both user space and in an OS environment model. I mean to say, like the classical OSD and in benchmarking programs and for that we can profile more easily, and then as side by side with whatever we do in the C-star model.
Matt, regarding specifically the FTL and Flash vendors, I actually had a meeting a year or two ago with one of the big Flash vendors where when they heard that we wanted to give them variable length data that was, large, when in their mind, large was like, bigger than,
a K,
like 512 bytes or something.
yeah, or half that.
Yeah, then they got really like kind of disinterested and nervous.
But everything we're doing with it, especially at the but especially that RGW is doing with it, is going in the wrong, is going in the opposite direction. That it's in. I mean, we need variable like keys. We need composite keys.
Yeah, exactly.
So we need the prefix concept. Basically, that's the math that's the tree math that leads to solutions.
When you say prefix concept, you mean
Prefix trees, tree tries.
Meaning that the keys are encoded efficiently, right? So
Yes.
if you have foo and food, it does a
Yeah, exactly. We have an efficient fan out for at the key level, and that's most of what we got to do. The separate thing you got to do that Whiskey shows and other things just do already is handle the data out of line rather than at least if or in some efficient way that gets collected later if it's going to be large. The Whiskey shows that even if you just they just did a little sort of a hack where they put pointers into the data, but then but somebody wrote this badger, so that's the mascot of the University of Wisconsin, of course. So this badger database, this Golang thing, is basically right from scratch a nice clean implementation of what of LSM with Whiskey's ideas in it. And it gets really good results. For some things, it's going to hit the same wall that LSM does, sadly. But if you moved out, but if you have quite a bit of data, you pull it out of the materialized, sorted part of the materialized index, then you materialize skip list to then you win. But I don't think it fundamentally changes the game. I think it just moves. For some portion of for some loadings from that are more data heavy, improves on the situation, but it still suffers from the same problems of I think the LSM acceleration does. But the key piece that's giving that what you're paying for there is to allow range based searching. Some people there's a whole lot of research about let's get rid of that, but of course that's obvious, but we can't get rid of that. So all that literature is dead to us. But prefix trees and are something we care about. It would be there are a lot of people in this situation, and they're also in this. Similarly, there are going to be a lot of people in this situation where they want to move to architectures, this new architectures like ScyllaDB, like C-Star. So I think that we won't be all alone in working on this, or that they join us in the Ceph project, or whether we work on something that shares effort with other people other ways. But I think we should get involved in doing that because it's an obstacle in everybody's way.
So I mean, yeah, clearly we need something better than RocksDB. I think that my concern is really just high level, like what should we be targeting? Should we be targeting a C-Star implementation that's going to be part of C-Store, or separated out from it, or part of that new world that's 2 years away? Or do we need to target some sort of short-term hack?
We need to come up in the middle. Perfect framing. We need to navigate between the Scylla of 2 or 3 years to land it and the Charybdis of short-term hack, because there's no off-the-shelf hack. We've already done that. It wasn't a hack, right. It was a nice, clean, solid thing, but we've hit the wall with it. I think we need a thing that can run in C-Star from early, but factors everything, but factors all the index structure ideas and a bunch of as much other comment code out into runtime independent units and can be used as an OS library in an ordinary way as well. It has been, we would focus more on operation. We would focus less, I think, on the optimization of the ultimate fastest lock-free, user space runtime. More focused on C-Star for that, but not be locked into C-Star to do all the work, and ideally to have something that can be run in OSD. I looked around for things that are commercial off the shelf, simple replacements for RocksDB. I don't think there's anything. Even Wired Tiger, which is the successor to BerkeleyDB, which I found out. There's so much Berkeley and MIT license on the main page of the license page. I say in my own defense that I didn't notice that the primary license is GPL, and we can't even touch it. So it's pretty much irrelevant. But even then, Keith Bustick and his key acolytes and key collaborators from Berkeley, from Sleepy Cat, are involved in it, but they're focusing on LSM, for goodness sake.
Yeah.
So for whatever, so useful as that could be, it isn't. Even that isn't going in our direction right now for whatever reason.
And it felt to me, I mean, it's been a while since I looked at it, but my impression when I looked was that there's a lot of complexity and emphasis on the transaction isolation.
Yes.
It's more of a database, and we don't actually need any of that. We just need to store.
Yeah, exactly. We make care at some level, but yeah, the emphasis can't be around optimizing a particular runtime path like that. It has to be around flexible management of index structures.
Yeah.
So there is a code base we can start from, but it's but there's nobody actively committing on it. So I think it's of interest to beat on that, and I've been working with it. I've been working on the key value interface for it, but I don't expect it. But in no way do I expect it to be a magic fix for anything. The interface, yeah, and in fact, even how about ForestDB now, the Couchbase version of it, which is the complete-ish one. Even then, even the APIs are dubious, and a mixture of the APIs that came from the Korea Institute and Couchbase, which we don't want, document driven and whatever. But having said that, in some ways, it's lack of deep commitment to a particular runtime is actually a benefit because it's probably going to throw half it away.
Yeah. So my go ahead.
Yeah. I was just going to say, from a very practical viewpoint, I actually started looking at ForestDB pretty aggressively after the LMDB experiment failed.
Yes.
And it looks like we could probably write a key value DB wrapper around it relatively easily.
Yeah, you absolutely could. And I've done part of it. I haven't run much because I was working on other things with it. But it's not. Yeah, and it's fine. But it's not a magic bullet. So so finding a way to get use of it early, yes, is good. It has some transactions and other pieces, so yeah, it can be done. But almost immediately we want to know. I just wanted to front that expecting it to be a quick fix isn't expected. And baking the interface, the key value interface is not the key piece. But yes, you can, and yeah, I think, and you were right to spot it early. So I'm just trying to buttress why, but I think that's right.
I am still of the opinion that we are abusing RocksDB, that we're really, really abusing it.
Well, not in a way, but not really. I mean, if you have a clear sense of it, but I think we're getting the results that you get with it when you put large data sets in it.
Yeah. I think we're getting the results that we get when we mix like a lot of long-lived and short-lived data together in one.
Well, that's a separate issue. So that's a totally separate issue. And we've covered it in other calls, so I didn't focus on it here.
Yeah,
but that is absolutely the case. If at least I think it is the case, and I think you corroborated it. Even though there's other reasons to believe other things, the empirical evidence I think does support. Logically, you want to separate out completely those things, and not just lie, but yes, the different time domain data essentially, and factor it out. But that work on that was going on, but it was most importantly though it's totally orthogonal to everything else. We could do it immediately if we have time, and it makes RocksDB work better if we could, presumably or should do. So work was ongoing to do that. I understood at Intel. What happened?
That's a good question.
Who knows, right? But they're not. We don't have any control over what they do or don't do.
I mean, yes, on a short to medium term track, if someone could actually effectively do that and then measure the results, we would expect improvement. To get pglog and pginfo specifically out of there, that'll help.
Yeah. I think that the high level strategic decision here is really about resource allocation and risk. Because I see sort of three paths in front of us. One is the making incremental changes to RocksDB, for example, to separate out the time-based stuff and get it going a little bit better, right? That's sort of path number one. That's relatively low risk. All the RocksDB integration's already there, likely to be accepted by the RocksDB upstream. So it's low risk, and it's, I think, relatively small investment, that we're not actually doing it. That's sort of path one. Path two is the long-term, 2 to 3 years. We're going to C-store. We're going to be writing something basically from scratch. We can make sure it meets all of our design criteria, everything we know going in, but it's going to take a long time to get there, and we need to like sort of bridge that gap, right? And then the third option is something in between that is going to replace RocksDB in place inside BlueStore in order to bridge the gap to get to CStore and C-star. And that strikes me as also a pretty large investment because of all the integration work that would need to be done with something like ORSDB in order to glue it into BlueStore. And it also, at the same time, strikes me as high risk because we actually have no idea what the performance is going to be. If once we do all that work, we can sort of like guess, but we really don't know what's going to happen.
Well, that's right, I guess, but I mean, and it's totally right, actually. I mean, I totally get that, but I mean, well, number one, yes, well, the most important part, but high risk piece, that adheres to both 2 and 3. I mean, we will ultimately get an efficient C-store, of course. Yeah. But the key piece, the insight I'm trying to bring to the positioning paper I'm trying to add here, or the logic here is one that both directions of 2 and 3. We could overemphasize using the solution as a piece of COTS, and 2, we could overemphasize the runtime as the runtime fit. You know, the C-star piece of it, or the current OSD piece of it in the other case. I'm trying to ask whether there's a way to do
both.
2 that hybridizes into 3. Possibly putting a question mark next to whether we would ever deploy a replacement to RocksDB, you know, in place in an Luminous code base or something, or Luminous or Rimic code base, but to have it as a side by side because, you know, working early because it might prove possible.
The focus is different.
That's a big open. I have to do some thinking about that because I've always assumed that the runtime is going to dominate the way that the code is written, and it's not going to be possible to like write something that can be adapted to run in C-star and also in a threaded context. Maybe that's not true.
Well, I mean, it can be true. I mean, it definitely could be true, but I'm interested in whether it has to be. Like you get systems like LMDB, which are sort of dominated by that, and certain luck, you know, and in some ways though, the different threading decisions that, you know, and having one thread doing, you know, having specific thread roles, you know, broken out into our code base and the current OSD makes it more true. And we sort of need something. I think one of the goals we'd like to have in the larger world around outside of us, you know, or including us, but the larger superset of people who are working on all these problems have a lot of different runtime configurations. You know, the C-star model might not suit all of them.
Yeah.
Matt,
well, maybe an interesting question here is whether the design of the store that is going to become C-store can be written in such a way that it actually could be. I think that's what you're getting at. It actually in place of RocksDB.
Exactly right. And my thought is
term.
Yeah, and this is the whiteboarding exercise. But as we actually started, you know, we want to build on what is known about indexing strategies and technologies that have existed before. The papers plus everything that went into 25 to 50 years on this, all the knowledge that we have to professionalize to get it out there. That's really the project and the runtime, and we can build it. And we should try to work on it in such a way that it is not fixated on our runtime constraints. Because then you get LMDB, or you get things that are really locked into. It's all about mmap, dude. And then now you get something that's twice as, you know, that works great on FreeBSD and sucks on Linux and other weird stuff.
Yeah,
I think the CSAR and kind of traditional model is one axis to look at, but the other really, I think, important axis here is what you want to do on flash and what you want to do on hard disk.
Well, that's right.
Hard disk, you know, RocksDB actually is probably a reasonable model for hard disk, right?
Yeah, it sounds like it. Yeah, it's what it's made for really good hard disks anyway. Not shitty ones, but really good ones as of 2005, yeah. That's the bubble it lives in. Because there's a reason why they didn't make this, you know, in 1978.
Yeah, I mean, BlueStore is kind of like the model for hard disk, right? I mean, it does a lot of things to try to make really nice,
the really great hard disk with deep queuing and other things, yeah.
Yeah. Whereas whatever C-star or C-store is going to be, I don't assume that is what we're.
You're right. I think Marlon Samuel is the ghost of Marlon Samuel. If you're here, I think he would agree with you. I think he would also say we can. I think we can route around it. Then we can. But the FTL piece, that's a piece we don't. I mean, that was another piece I brought in. I had to think about this. One, it's not my area of expertise, but I think it's a specialized area of knowledge that we want to factor out, and we want to bring in the experts and the people that are with their particular hardware profile into the mix to help if they can.
If you want to make the C-store key value database useful for hard disks, you're going to need to prioritize or think about sequential allocations. I don't know that you want to go down that path.
Yeah, but I'm going to jump right to Sage there. I think Sage counter. Yeah, let's go there. Let's not go there.
Yes, I agree.
There's no reason. Yeah.
And at that point is even worth bothering with Blue Store though, because do we?
Well, no,
really
that's what I'm saying. Yeah, but no, I think that what Matt's point is that there's like the first half of the work on C-store or whatever it's going to be called. That's basically around the design of the data structures, the behavior of the indexing, all this code that needs to be written in order to actually work. That actually is independent of the fact that you're running it in C-star lockless context or in a threaded model. And we can do all of that work and do all that design work now. And it may be that when we get to the point where we're ready to start working on the runtime, that it's possible to glue it into Blue Store before the rest of the OSD is rewritten in C-star and get some benefit there. That's possible.
Sure.
And other people could, and we'll find out when we get there or we get closer to that. Right. But as other people join the project and help us out, we may find we can invite them to use it in other workload profiles and other runtime product environments that we haven't thought of. But when we give them those primitives, they'll say, oh, I can work on
right
mmap or sequential access friendly model and threaded or whatever, and they can help us cross-cut that.
And I think that the key is that the hard disk shouldn't pollute that thinking at all, because this never needs to replace RocksDB. It could be used instead of RocksDB, but you would run BlueStore RocksDB on hard disks, and you'd run BlueStore or on SSD. So
potentially, that's right.
Hard disks should never be mentioned again. Right.
It's just you're adding more that you have to think about, right? This can be hard enough designing BlueStore or C-Store's key value database on just at all, but now you're kind of adding more things to the list of things you need to think about.
Well, that's what I'm saying. We should remove hard disks from that conversation, and so then the only additional thing that we need to think about is running in a threaded context in a C-star context, and I leave that as a maybe. I'm still skeptical that we really want to go down both paths, but I'm willing to see that it might work in both cases. But regardless, we need to do all the initial work around like what are the data structures going to look like, what's the runtime behavior going to look like in order to actually make this work, and figure out whether it actually makes sense and do that. But we're out of time, and then my doorbell just rang, so I got to run.
Okay.
Well, thanks guys. That was pretty fun.
All right. See you guys.
See you later, guys. Have a good day. Have a good week.